Hello, in this video, I'm going to walk you through some examples from chapter 2. So we'll start with the repository. At this URL, I'm going to go to chapter 2 and look at examples. We're going to start with the environment interface. So what we're trying to do here is to define something called an environment, which is like a dictionary. Given a label, a name, it can find the value associated with the name or a variable and its associated value. So our textbook defines the environment as a function. So it maps a set of variables to a set of values. So the values are all scheme values. So they can be all kinds of things, but we can, so this function is really a set of ordered pairs, right? So we're gonna look at a few different representations. So the easiest way is to use the data structure representation. So here is example. We're gonna test our solution this way. So here so the data structure representation follows this grammar, right? So we have this so we have this thing called environment. We're trying to define it, and then we need two ways to construct the environment. One, we're going to start with the empty environment, a representation for empty environment, and then we need a procedure that, given a saved environment, we want to be able to extend it with another identifier or a name, and followed by a value, right? So what we're trying to have is this. I'm going to draw on our whiteboard. So we're going to use, in the data structure representation, we're going to use the easiest way is to use a empty list as the empty environment, and when we need to add something new, we'll just add another we'll need to x equals to 3, and we could create another list, right? And then we extend it this way. So now we have the save environment as the last element in this list, and we have the variable and its value. Now if you want to extend it again, we just put another pair, name value pair in front of it, and that makes another list, right? So scheme, we have seen quite a few examples on how to process this kind of data structure, right? So this is be a natural way to do that. So so this program does exactly that, and we have some test cases. So I'm gonna copy this, and I'll walk you through this implementation. Paste and run. Okay, so here we have some comments, right? We're defining we're defining a set of procedures as interface to this thing called environment, right? So the chapter is about data abstraction. So we're trying to separate interface and representation or internal representation. So our goal is to have this set of procedures that is all we need to know as from a client code and from a client perspective to use this data structure, right? How it's implemented under the hood, behind the scene, is irrelevant. So our empty environment is going to be a function, takes no argument, but maps to something called environment, right? A representation. So here we represent the environment using the empty environment using a list, right? Use the scheme function procedure list, and we put a label. So this is called a tagged list. So an empty environment, when we call empty environment, what we get is really a list with a one symbol called empty, and then that's it. The only thing is that. Okay, so that's what that's the design. Okay, and then we're gonna see the alternative designs later on. So extend environment is another procedure. Given a variable, a value, and the saved environment, we're gonna create another list with a label called extend environment with the elements, right? So let's visualize it. So to put x and 3 into our new environment, store x equals 3 in the new environment, we need to extend the saved environment, extend it, and then that's a label, and then that's our list. Okay, so that's what we're doing in this second definition. Okay, now the most useful part is apply environment, right? So apply environment is a function that maps an environment and a variable combination to a scheme value, right? We're looking up something by name in our environment, in our dictionary. So this is a procedure. Given environment a search for variable, we're gonna look into this kind of structure and find and search to find the matching variable. So what do? Well, we're gonna use cases. We're gonna divide into cases, right? If the car, we look at the label, if the car of the environment is empty environment, we're gonna report an error because if it's empty, it can contain nothing, no definition. So that's an error, so we have a help service procedure there. Otherwise, if it's extended environment, if it's this label, that means it's extended environment, right? So then we know that when we create the extended environment, we have a variable, it's a list. We're gonna make it as a list. The first element is always the label, followed by the variable name, the value, and the saved environment. So we're gonna use the let expression to define some temporary variables, names for the variable. So the car of the coder, the second element, the third element, and the fourth element. But give them names so it's easier to write our program. So now if the search variable matches what we have stored in the extended environment, the variable in the extended environment, then we return its corresponding value. Otherwise, we're going to recursively search in the saved environment, right? So we call apply environment again to search for the search variable in the saved environment. So here, effectively, we're trying to, let's see, we want to find y. Well, y is not, this is not equal to y. So we search in the saved environment, and it's going to cause an error because y is not defined there either. Okay, so that's it, right? So now, given this interface, we can build an environment like this, right? So we start with empty environment, but then we extend it, we extend it, we extend it, we extend it, and then we give it a name. So in this extended environment, we have x, y, y is defined twice, and then d. So that's I'm gonna run. Okay, I already run the definitions. Now I can try this. Oh, actually, I can print e. This is very handy because the internal representation is just a scheme list, right? As you can see, this is exactly what we have imagined. Each extended environment, each environment is a list. An extended environment has a label, and then an empty environment has its own label as well. But then in the extended environment, we also have one variable, one value, and then in the extended environment, we have one variable, one value, so on and so forth, right? So now let's test whether this works. I'm gonna copy that. So we're using apply environment procedure to look up x. So give us 7 because first 7 is x is not here, x is not here, but x is here, right? So we found 7, and then that's the correct value answer. Let's search for y. Apply environment and search for y. We found it here, so the corresponding value is what's being returned from the procedure. And then there's another y defined here, but we're not going to find it because we have another definition that is closer, well, from outside in, if we search from outside in. And then let's search for d. That should give us, should find the definition and give us its value. That's not a surprise. And if we search for z, the variable z, which is not defined at all, so this should result in an error. Okay, so that is the first the first way to define a to represent an environment. We call it the data structure representation. So we have three procedures, and they work together, right? They conspire to create this interface to this thing called a environment, through which we can create the environment, and we can to store values, name and value pairs, and then we have a way to look up the values given a name of a variable. Okay, so that's it.